the previous class where I described the Rutherford model, there we have seen that atoms is considered as the small scale solar system and its nucleus is like sun and the electrons is like lighter planets. So we can apply the classical mechanics to describe the solar system. The gravitational force between the planets is given by the expression, what is this? Capital G dot M1 M2 by R square, where the M1 and M2 are the masses and R is the distance of separation of the masses and capital G is the gravitational constant. This theory can also calculate, you know that R we can calculate very easily, and on that basis we can see the radius, we can calculate the radius of the planetary orbits, and this is a good agreement with the experimental results. Now the similarity between the solar system and the nuclear model suggests that the electrons should move around the nucleus in well-defined orbit. The Coulomb force, which is denoted by the equation K Q1 Q2 divided by the R square, where the Q1 and Q2 are the charges and small r is the distance of separation between the charges and small k is the proportionality constant between electron and nucleus, is mathematically similar to the gravitational force. However, when a body is moving in an orbit, then it will get the acceleration even if the moving is at constant speed, because in orbit that body is changing its direction. So in this case the electron also in this nuclear model, it is act like the planet and orbit is under acceleration. It should be, because the thing is that electrons is moving under a constant speed and it will get the acceleration as per this point. According to the electromagnetic theory, that means here electromagnetic theory we can apply, then the charged particle, here we have seen the electrons, when accelerated should emit electromagnetic radiation, and in this case is not applied to the planet because planet is the uncharged particles if you consider as particle. Therefore, the electron in the orbit will emit the radiation as per the electromagnetic theory of the Maxwell, and the energy carried by radiation comes from the electronic motion. The orbit is thus continued to shrink. So whatever we understood that the planet in the solar system is not charged. So in this case, in that case, it is not possible to emit radiation. But when is the electron is the charged particle, and this charged particle will emit the radiation, and by emitting the radiation, these electrons in its orbit will continue to shrink, and calculation shows that it should take an electron only 10 to the power minus 8 seconds to spiral into the nucleus. That means if it is electron and if it is the nucleus, then it will come in this way, and it will collapse on the nucleus, and it will take as per calculation only 10 to the power minus 8 seconds. But this does not happen. Thus, the Rutherford model cannot explain the stability of an atom. Because if electron is the charged molecule, negative charge, so it will emit the radiation as per the Maxwell's electromagnetic theory, and it will immediately collapse on the nucleus, and so the Rutherford models cannot explain the stability of an atom, and that is the drawback of the Rutherford's atomic model. If the motion of an electron is described on the basis of the classical mechanics, whatever we described, and electromagnetic theory, then you may ask that since the motion of the electrons in orbits is leading to the instability of the molecule, then why not consider the electrons as stationary around the nucleus? That may be one question it may arise in your mind. Then you will see what will happen. If electrons are stationary, then what will happen? The electrostatic attraction between the dense nucleus and the lighter electrons would pull electrons towards the nucleus to form a miniature version of the Thomson's model of the atom. When we describe the Thomson's model of atom, then we have seen that the positive charge, it says that moving here and there, and if you consider the atom like a watermelon, then on the surface it is moving here and there, and electrons are moving inside like the seed. Consider the electrons are stationary, then it will be pulled by the dense nucleus, and it will be same like the Thomson's model of atoms. And another serious drawback of this Rutherford model, that it says that nothing about the distribution of the electrons around the nucleus and the energies of these electrons. That means Rutherford's atomic model will not give any idea of how to distribute the electrons around the nucleus and what is the energies of these electrons in each distribution.